Okay, all my students, I hope you are all well. Now I am starting your class. Today our topic of discussion is optics, that physical optics. Now we discuss about the theory of superposition of two light. Theory of superposition of two light waves of same wavelength. That is theory of superposition of two light of two light waves of same wavelength. Now let us consider two sources of light. Now we draw the figure first. That is one of source S1 and another source S2. There are two sources of light of same wavelength. Then the screen, this is screen S. Now from these two sources, now from source 1, one light wave goes through the path through this path, just like light wave goes through this path and incident at point P. Also from the second source S2, another light wave goes and it also meets at point P. For this, it is superposition is caused. Then the distance from the source and screen, so the middle point of these two sources, that is S. Let us consider that is S, and the shortest distance from the source and the screen is this point O, that is SO. Okay. Now we describe this subject, that let us consider two sources of light S1 and S2, each of which emits light wave of same wavelength. There is a screen at a large distance from these two sources. We want to calculate, our aim that to calculate the resultant intensity of light at any point P on the screen. Our aim, we want to calculate the resultant intensity, resultant intensity of light at any point P on the screen. Now, the electric fields of the light waves reaching P from these two sources S1 and S2 are given by the electrical field that is electric field of the light waves fields of the light waves reaching at P point P from these two sources S1 and S2. These are gradually E1 equals I cap E0 e to the power E01, that is source number 1, so we are calling this E01. Now E01 e to the power minus I cap minus I into omega t minus phi 1. Here phi 1 is the phase difference. Now also from the second source E2, electric field E2 equals I cap. I cap means along x axis, only along x axis, and E02 this is coming from the second source, so we have E02 and e to the power minus I. I means here complex number omega t minus phi 2. These are two electric fields, and now for these two electric fields conjugately superimposed to each other, then total electric field, that is E equals E1 plus E2, that is equals I cap E01 E01 e to the power minus I omega t minus phi 1 plus I cap E02 e to the power minus I cap minus I omega t minus phi 2. Okay, then adding these two quantities, I cap E01 e to the power I phi 1 plus E02 e to the power I phi 2 e to the power I omega t. equals I cap E0 e to the power minus I omega t. This is the final addition, final quantity of electric field, that is electric field equals I cap E0 e to the power minus I omega t. Here E0 is the E0, here E0 is E01 e to the power I phi 1 plus E02 e to the power I phi 2. This is the amplitude, this is the amplitude 1. So the resultant intensity, intensity I is proportional to the square of modulus of the resultant amplitude. So we can write that the resultant intensity I is proportional to the square of modulus of the resultant amplitude E0. So that we can write I equals k, any constant E0 and its modulus, its whole square, equals k into E01 e to the power I phi 1 plus E02 e to the power I phi 2, and also multiplication of e to the power E01 e to the power minus I phi 1 plus E02 e to the power minus I phi 2. These two terms are multiplied. Now totally it comes from intensity I equals k, any constant, into E01 its square plus E02 its square plus E01 into E02, and totally multiplied to another e to the power minus I phi 2 minus phi 1 plus e to the power I phi 2 minus phi 1. The first term here is minus term, and this is the positive plus term. Second term is positive term. Now in simplifying we can write k with simplify we can write this is E01 its square plus E02 then its square plus E01 E02 and whole multiplied, that is cos 2 cos phi 2 minus phi 1. Now totally so that k multiplied E01 square plus E02 square plus 2 E01 E02 cos phi 2 minus phi 1, that is equals k E01 square plus E02 square plus 2 E01 E02. 01 means from the first source electric field and 02 from the second source electric field. Cos here cos delta, that is phase here phase difference equals delta phi 2 minus phi 1, that is where delta equals phase difference. Very interesting term. So the intensity I equals intensity I equals totally we can write that I1 plus I2 plus 2 root over I1 I2 cos delta. Very important and interesting term here, where intensity from the first source I1 equals K01 E01 square, and also intensity from the second source, that is I2 equals K E02 its square. Now some special cases are accepted here. Now from the case 1, when the two sources S1 and S2 are coherent, then delta, the phase difference, does not change with time. When S1 and S2, these two sources are coherent, delta does not change, delta equals constant, that is phase difference is constant. The point on the screen where for this case the delta become plus minus 2n pi, when n the integer, that is n equals 0 plus minus 1 plus minus 2 etc., then I max will be I1 plus I2 plus 2 root over I1 I2 cos 2n pi. Why? Delta equals 2n pi. Now it will be root over I1 plus root over I2 and it's totally whole square. It will be I maximum intensity, and this also be when I1 equals I2 let us consider this value equals I0, then also I max will be 4 of I0. Very interesting result. So the phenomenon is getting intensity at the screen is called the constructing interference here, constructing interference, and here constructive interference is produced. Okay, now for the minimum case, minimum intensity, for the minimum intensity I min equals I1 plus I2 minus 2 root over I1 I2. When is it possible? When then it will possible when the phase difference will be 2n pi, and lambda by 2 pi into phase difference, that is path difference when delta equals lambda by 2 pi into 2n pi in this case. So that for when I1 equals I2 equals I0, we have said then I of minimum intensity equals 0. This is the phenomenon is getting minimum intensity at same point on the screen in terms of path difference, and the graphical interpretation, it will thus and intensity from y-axis intensity and x-axis phase difference, that is 0, pi, and it will 2 pi, 3 pi, and so on. Negative side minus pi, minus 2 pi, minus 3 pi, etc. Then when minimum pi, 3 pi, minus 3 pi, these phase difference, these are the position when it will minimum intensity. Okay, no, not so much today. Now another cases will be discussed next day. Okay, thank you to all.